we're gonna try this again. We're having environment issues, but they seem to have sorted themselves out after refreshing. But now I'm 15 minutes behind schedule, so we're just gonna jump into it. So now there's this funny thing happening where Rust Analyzer thinks that none is meant to be a variable here. There's an ongoing and active debate on a GitHub issue about this, so I assume it will get resolved at some point, so I'm just going to do my best to ignore it for now. Okay, so predicates is where we're going to jump back in. So this is in transformation. Get predicates doesn't exist, which is fair enough, but I think the bigger thing is predicate takes a symbol node. So we are going to update this to take binary symbol trees. We'll just bang through all of this and say symbol node becomes binary symbol tree. Boom. And now things should yell. Oh, here too. Didn't that? Can I just do this? No. Okay, so now this should be fine, but then normalize we're gonna have to do differently. Okay, so the point of a predicate is that it encodes basically a statement with that's got a parameter to it. So if you had like, I don't know, x equals 5, and you wanted to think about that statement as a function of x, where x can vary, the predicate type is what wraps that up. And we need that for reasons that I'm not going to get into. So this normalize function basically takes the predicate has a node, and it has a part of the symbol tree that's arbitrary. I don't really love the name node as I'm thinking about it. What statement? And normalize just means we're going to rename it in a way that's always consistent, so that the same, so x equals 5 should be the same thing from a predicate perspective as y equals 5. And so this handles that. So we get the symbols. Max ambiguous. Okay, right. So we're gonna number them essentially. I think for now what I'm gonna do is just make this, oh, it needs return. So is this a thing? Unclear if that's a thing. You might need to re-implement that. It's not yelling at me though. It's hard with all these red icons that I don't know why they're red. Okay, replace all from symbol doesn't exist. Let's take a look at that. So binary symbol tree has relabel all, has with child replaced, and with child replaced at. But I don't know, is this really what I want? Node to return and arbitrary to return. Let's rename these to be consistent. Statement to return. This should be called statement also. I feel like we just did a replace child with child replaced. It's the ith child. Okay, maybe we never needed to search it. But we could do with symbol replaced. So we can do pub function with symbol replaced. Self symbol, symbol, new child, self, or new, say replacement. Return a thing. Yeah, it should return a thing. And then we just do match self dot node trees dot get symbol dot get name none, then we return okay self clim some encoding, and then we do, wait, did I end up implementing get indices? It did. It takes a label. So let's actually do self dot get indices. This returns what? This returns a vec of u sizes. Okay, fair enough. So really we can just do dot for each. We need intuiter here. Intuiter would also work. I guess intuiter is fine, they're copy. For each self dot with child replaced. It's not really for each though, is it? It's really either fold or reduce. Can never remember which one's which. Something like this. With child replaced at replacement. Collect. This can return a result. So this should be trifold, or maybe try reduce. I still don't remember. Can I get some help on a trifold? No. It probably shouldn't be a 2-ball. This method takes 2 arguments. Oh man, I actually made it to the mic button before I sneezed. Remarkable. Okay. So is it reduce that I want? I don't though, because I need... No, I just need... Self.clone is what starts the accumulator, right? Ugh. What awful thing have I done? Oh yeah, we don't have to collect that. It's just gonna work now. This is gonna be the first time ever that I just use fold correctly from the get-go. Cannot get a help out of it no matter what I do. Alright, well. So this now will be this child. Something like that. What did I call it? With symbol replaced. With symbol replaced. With symbol replaced. I feel like my debugger is just being incredibly slow, is what I think. That symbol should be better. Oh no, that still needs, okay. And now what's the issue? Can I do this? Why can I not get signature help? Weird. Okay, let's return something that throws a symbol node error. This does not do that. Okay, when can this ever throw? It throws when get child index is bad. We know it's all right though. So we can actually just fold this and say .expect. We know the indices are fine. Okay. Get symbol names is not a thing. And replace all is not a thing. Okay, get symbol names is easy. Binary symbol names, blah, 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 somewhere in here. Get symbols, let's do it here. Okay. Replace all. With symbol replaced won't quite do it. We can do it recursively. Is there a better way to do it than to do it recursively? Yeah, we can scan the binary encoding one time, record all the places that it matches, and then update them all. Relabel all. I feel like I kind of did before. Didn't I do that as part of substitution? Yeah, like here. The difference is that all I had to do was check the label. But I could write a find function that scans the binary tree and just returns any instances of it. It's not terrible. Alright, let's cloud compute on that for a moment. We'll replace arbitrary using predicate. It's also very recursive. Is there something easier I can just burn down? Get typed relabeling. Right. Get typed relabeling. Is it not just this? The difference. The difference is that we're meant to be using hierarchy to do something. What is going on? Oh, we should update those too. All right. Let's stop this for a moment to do. Some intos on here. minus a statement. This is going to get updated anyway, so I didn't really have to change that, but whatever. Actually, no, I did. I kind of did. It's fine. Might not like this because it might be creating a temporary reference. Sure. Nope. It's good. So many tests. Okay. Okay. I mean, it's kind of just still true. Okay, so I think we want to have a find function that can find a binary symbol tree within another. Like get indices. Their key size. And what to do? I guess we say for I and 0, we'll do mu to return new I and 0 subtree dot length in bits. Nope. Self.length in bits. If self dot get subtree starting at I equals subtree to return push I to return. Seems fairly sane. I imagine this is going to be a problem because, yeah, this might not exist. This is going to be a little slow. I think it's going to be like the triangle thing. Expected binary symbol tree bound. Yeah, I get it. Don't want to clone it. If let some self subtree equals this. If self subtree equals subtree, then this. Yeah. Okay. And so now replace all. Can just be indices be self dot find from and then it's just the same thing. To iter fold Wait, do we? Why is this different? This can just be self, right? I have to set the accumulator to something, right? Okay, we return the accumulate, the thing that goes into the accumulator. So that one seems okay. Why is it oh. It's just this. Okay. Okay. Implement those. Somewhere we have a to-do. Here, not that one. This one. Okay, so the thought is that it's the same thing as this, except when we check types, we need to check them better. Self-type, other type, so here it's got to be some hierarchy thing. Get typed relabeling. So all we do is we check that the self type generalizes the other type. Okay. So hierarchy generalizes. Methods are incorrect. I imagine we can just do this. Into this. I couldn't convert the error because we don't ever return this. No, we do. That's the problem. Oh, we can't convert it probably. So we generalize it, and if it's not okay, we throw. But only if it's not okay. What is this? What if it's false? I don't totally understand. Okay, I think this is what we want. What's wrong with these? Uh-huh. Okay. For now, let's just do self.into. Into. This is gonna be slow. Okay, and then we need a substitution at the end of this. New inner. What does substitution take? Takes a hash map of symbol name to binary symbol tree. Substituzione. Okay. Needs to be a map from string to binary symbol tree. Contains key. Map, label. Fine. So I think that one's just okay. This one is not okay though. This. something like this. What is it? Okay. All right, no more errors on SymbolNode. So now we need get predicates and replace arbitrary using predicate. Getting close though. Okay, what does get predicates do? Oh, fun. Alright, I know I've only been going for an hour, but I'm not feeling like jumping into this one right this moment. So I think I'm going to call it here, and I'll be back on Monday, hopefully. And we'll start with this get predicates, because this guy's a little dicey. We're doing some... basically get predicates is for every, like, given a symbol node or given a binary symbol tree, what are all the predicates that can come from it? So you have to compute all the different subsets. I don't think it's too bad. In fact, it might just end up being like a copy paste mostly, because it's implemented in terms of higher level methods that I might have already implemented. But I'm just gonna start there next time. Cool. Sorry for the short stream and the false start, but making progress here, and I'll catch you later. Thanks.